Welcome to the notes on the slope of parallel and perpendicular lines. Real quick, let's review vertical and horizontal lines. So the first thing, it says, remember that vertical line, the slope is undefined. Undefined. It's not zero. The slope is undefined. So if we look at this, they will always take the form of x equals some constant, okay? Some constant. I'll just put c there. Because right now, if we look at this point right here, that point as an ordered pair is whatever that constant is, 0. Okay, so the equation will just be x equals c. Now, in this example, we can clearly see that this spot right here is actually the value of 3 because we count 1, 2, so this is 3. So this point would be 3, 0. That's the x-intercept. Well, then my equation of this vertical line would simply just be x equals 3. Okay, so just kind of keep that in mind. All right, horizontal line, we have the slope of 0. So remember, horizontal line, the slope is 0. It's not undefined now. So remember, slope-intercept form is y equals mx plus b. All right, well, if I put in a 0, if I put in a 0 for x, well, that term is just going to drop out. So our form is going to be y equals b, whatever the y-intercept is. So if you don't see an x in the equation, just y equals, that's a horizontal line. So if we look at this point is normally 0, comma b. All right, so y would equal b. But in this example, if we count, we can see that this is -1, this would be -2. So this point would be 0, -2. So our equation would simply be y equals -2. So that's what a horizontal line looks like. Two quick examples. They might ask you something like that. If the slope is 0 through 2, 6, well, we know that it's a horizontal because it has a slope of 0. And we know that y equals b. Well, y will equal whatever the y value is. So this equation would just be y equals 6. A vertical line, we know that's undefined, so it's going to take the form of x equals, and we just look at the x value. X equals 1. That's how you do vertical and horizontal. Now let's take a look at perpendicular and parallel. Parallel lines, okay, parallel means not intersecting. All you need to know is they have the same slope. Really simple. All right, parallel lines have the same slope. If we look right here, this top line has 3/4 x, so we went up 3 over 4. So does the bottom one, up 1, 2, 3 over 1, 2, 3, 4. They have the same slope. Parallel lines have the same slope. That's all you need to know. Now, opposite reciprocals for perpendicular lines. Remember, perpendicular lines, what that means is that not only do they intersect, but they form a 90-degree angle. That's a symbol for a 90-degree angle. Now, they are always the opposite reciprocals. Opposite refers to the sign, and reciprocal, that refers to flipping fractions. So I'm just going to write flip right there. So let's do a quick example working with opposite reciprocals. If I said, what is the opposite reciprocal of 5? Well, 5 is positive, so I know my new one would have to be negative, and it would actually be 1/5 because that 5 is really over 1. So don't forget about that. That's how opposite reciprocals work. Here's a quick example. You can clearly see if this top one is 3/4, this one is 3/4, well, then my bottom one has to be negative because that's positive, and flip the 3 over 4 to 4/3. So perpendicular lines, opposite reciprocal is their slope. Here's some questions they're going to ask about that. It says, find the slope of a line that is A, parallel, and B, perpendicular to the line through the pair of points. Well, the first thing we need to do is we need to find our slope. Remember our equation, y2 minus y1 over x2 minus x1. So here's our points. I'll call this one x1, y1. I'll call this one x2, y2. So I simply plug those points in. So let's find our slope first. M equals y2, we said is 4 right here. So it's 4. It's always minus. And then it's minus a -2. And then that's going to be over our x2, which is right here. I'll put a box around that. That's our 1. Since I did 4 first, I have to do 1 first. Minus, and then that's a 6. So this equals 4 minus a minus. That becomes +2. So 4 plus 2 is 6. All right. And then 1 minus 6 is -5. So our slope is -6/5. So for A, if it's parallel, it has to have the same slope. So I'm just going to put -6/5. All right. And then for B, I'll scroll down a little bit. All right. If we want a slope that's perpendicular, that means it's the opposite reciprocal. So since this is 6/5, all right, it's going to be positive, and then we're going to flip the 5 over the 6. So there you go. And then the last one, determine whether each pair of lines is parallel, perpendicular, or neither. Again, all we're going to do is look at that slope. Make sure it's in y equals mx plus b form. Is y by itself, all right? They both are, okay? So now all we need to do is look at the slopes. 1/5 here and negative 1/5 here. So they're not the same, so they can't be parallel, so it's not parallel, all right? Now, are they opposite? Yes, they are opposite. One's positive, here's a positive, all right, here's the negative. But are they reciprocals? Are they flipped? They're not. So it's not perpendicular, so in this case, it would be neither. So there you have a little review on vertical and horizontal lines and the difference of slopes between parallel and perpendicular lines.